our lesson 1, vertical asymptotes. So the focus on this is going to be looking at graphing rational functions. So our goal is going to be with rational functions to find the domain and a vertical asymptote. And we're going to find that today by factoring. So the first definition we're going to see here is a rational function. A rational function is really any rational expression, and really it's just dividing two polynomials, right? So we just finished a unit talking about graphing polynomials. If we write two polynomials as a fraction, that's essentially a rational function. So we can see ones such as f of x equals 1 over x, which we're going to later see as like a parent function. We can see ones where it's maybe just a value and then maybe an expression on the bottom. Or we can see kind of a combination where we see some different polynomials that are being divided, and maybe we eventually have to do some factoring. Whenever we're talking about variables in the denominator of a fraction, what's going to happen is we're going to pay really close attention to the domain, and that's going to end up affecting what values that our outputs are going to be, and create what we call a vertical asymptote. So this is going to be a vertical line that we see on our graph, that as our graph approaches this imaginary line, it's going to extend infinitely, either in positive infinity or negative infinity. So we're going to want to pay special attention to the domain. So in these first three examples, the first thing we're going to think about is that when we have a variable in the denominator, there's certain values that we're not allowed to have. And specifically, we can't have our denominator equal 0. So if I can't, for this example, have x equal to 0. The reason for that, if I was to do 1 divided by 0, we actually would get undefined. And so there's no such value that 0 times a value would give me 1, right? So the inverse wouldn't be able to hold. That's why that's actually undefined. So if I set the bottom equal to 0, this basically tells me what I'm not allowed to have in my domain. So my domain really is going to be all real numbers, except x cannot equal 0. This is going to be written a couple different ways. So some people like to write it like x such that x cannot be 0. You might have it where you just simply write x cannot equal 0. For the sake of time, I'll just maybe write just what it's not allowed to be. But basically, 0 is not allowed in this function. So if we go ahead and take a look at the graph, a rational function, you're going to see a couple different pieces. There's going to be specifically two pieces, right? So we're going to see that I have like a left side of the graph and I have a right side of the graph. And both of these, as they approach x equals 0, which I'm going to put a dashed line, they don't ever cross that line. They're going to start going to either negative infinity or positive infinity. So when they get closer and closer to that, the number is going to get very, very large, but it's never going to hit that actual 0. Okay. So what happens is that dashed line is actually a vertical asymptote. So I'm going to write it as a vertical line. That's going to be x equals 0. And so by finding our domain, that's going to help us, in this case, find our vertical asymptote. So we're going to have a vertical line at x equals 0. So for rationals, again, you're going to have two different parts. We're also going to later talk about horizontal asymptotes, but for now we're just doing vertical. For the second example, we're going to see the same thing. If I want to find the domain, I'm going to first look at my denominator and just set that equal to 0. So x minus 1 equal to 0. And it's faster to find what x is not allowed to be. So I get x is equal to 1 because if I do 1 minus 1, I get 0 in the denominator, which I don't want, right? So my domain is going to be x such that x cannot equal 1. All right, or maybe you just simply write x cannot equal 1. What that means then is our vertical asymptote is at actually a vertical line at x equals 1, right? So it's almost like you're writing the exact opposite for the vertical asymptote. So we're going to have a vertical asymptote at x equals 1. So as the graph approaches 1, it's going to go to positive or negative infinity. And then finally, the last example, same thing. I'm going to go ahead and take a look. And there's nothing, I can see I have multiple variables in this one. If I look at the top, I can't factor it. The bottom, I can't factor it. We're going to always want to kind of look at that first. It didn't really matter for this example, but then I'm going to take a look at the bottom and do the same thing. I'm going to set it equal to 0 to find out what value am I not allowed to have. So we have 2x equals negative 1. I'm going to solve. I get x equals negative 1/2. And so my domain is that it's not allowed to equal negative 1/2. Or my vertical asymptote is at negative 1/2 or negative 0.5. And so if I look at this graph, I actually do have a negative asymptote at negative 0.5. So as the graph goes closer from both directions, it's going to extend to positive or negative infinity when it gets closer to that vertical line. For the examples that we're going to look at, the question just simply says, find the domain and the vertical asymptotes, right? So what we always want to look for first is if we can factor. So I can see that, and even if we're not using the numerator, we're going to find that looking at both pieces is going to be helpful later in the unit. So we'll just get in the habit of doing it now. The top part, nothing really factors with it. We can't group or anything. So I'm going to look at the bottom. And to find my domain and vertical asymptotes, I'm going to have to factor. So we have to use the stuff we learned last unit. So we look for GCF. We don't have it. It's not one we can do grouping, but I could actually make a little table, right? So factors of 8 that add to 6. And we'll find that we don't even have to write all this anymore, right? Because we should hopefully be pretty good at factoring by now. And so this would be x plus 4, x plus 2 on the bottom. And on the top, I wasn't able to factor anything. So maybe I don't even rewrite it. I'm going to rewrite it just for the sake of this example. And now if I want to find what my domain is, I'm going to go ahead and take my bottom piece. And then I'm going to set each of these to 0. Using my 0 product property, I get negative 4 and negative 2. And really, again, that tells me my values I'm not allowed to have. So basically, my domain is going to be x such that x cannot equal negative 4 or negative 2. Or maybe you list it out, right? So lots of different ways you can write that domain. For my vertical asymptotes, again, it's almost like you're writing the exact opposite. So that means when the graph approaches negative 4 and when the graph approaches negative 2, it's going to go into infinity. For question number 2, it's basically the same thing. So I'm still going to look at the top even though I don't need to use it to make sure it's factored. It is. And the bottom, I'm going to go ahead and factor that out. So we can see that 2x squared minus 7x plus 3. I have to do some grouping. So factors of 6 that add to negative 7. I'm going to go ahead and use a negative 6 and negative 1. And so we're going to go ahead and group that out. So for this example, I'm going to write the factoring. But at this point, again, this should be something you're actually pretty comfortable with. We spend a lot of time factoring because it does pop up in this unit. So we get x minus 3, x minus 3, and so forth. And then we're going to set each parenthesis to 0. And then this would be a 1/2. And so for our domain, remember that that's giving you the values you're not allowed to have. So we are not allowed to have 3. We're not allowed to have 1/2. And then our vertical asymptotes are going to be the opposite. X equals 3 and x equals 1/2. And by opposite, I don't mean the opposite sign, like a negative, meaning that, x equals 3, that vertical line is where it's going to approach infinity. If you have any questions, feel free to ask them during class. Sign up for T-Bolt time or go to the center.